Yeah, so I don't have, like, the slides are like one. That's what I was thinking. And I'll switch back and forth. Oh. All right.
You wouldn't be the first actually to discover vulnerabilities. This is one time where we had people like forcing themselves into different office hours.
All right. Hey guys, welcome back from lunch. So for the rest of the topics, I don't have as much like lecture material. It's more like maybe like 1 or 2 slides on just like different things on this topic. And then what I wanted to do is launch into some of the example problems that you'll see from like this actual CTF that we'll do later in the day. So I have so like for forensics, I have a slide and then a selection of problems. So what I was hoping that we could do is that we'll kind of start at the top of the list and go down maybe 2 or 3 of these problems, and you guys walk me through doing it. So rather than me like doing it and showing you how it's done, I want you all to like actually drive this all together as a group. And then at the end of the day, we'll have maybe 2.5 hours to 3 hours of an actual competition, and we'll talk more about the logistics of that in about an hour. That sound good to everyone? Cool. All right, so forensics problems. I talked a little bit about this earlier, about like what sorts of things you'll see in competition setting. A lot of it is like, here is data, find something hidden inside of it. So here's a jar file or a zip file, which are, I guess, the same thing. Find the flag, right? Like that's it. That's what you're given. You have to untar it and maybe look through the Java class file and figure out which string is important. Or here's a actually there's one that we can go through. Here's a GIF. Find the flag. It's an animated GIF, right? So one of the screens on the GIF shows the flag. How do you extract just that image, right? Or here's a PDF. It was redacted. Find what was redacted. Like find the text out of the original document, which that particular case is actually some famous security leaks have happened because of that, poorly redacted documents. So the military has a very bad history of badly redacting documents and people going Control-A, Control-C, Control-V, and finding all the text that was supposed to be hidden. Like, yes, exactly. So forensics is all about that. So that's a lot of that finding hidden information. Things that are useful to know, file types, or at least useful to know how to Google, right? So a lot of this is going to be Google it. Like, I have no idea what I'm looking at. Pick out keywords, throw them in Google. Stack Overflow will tell you what you're looking at. So file types are things to look for. And just like the 5-second overview of how files work. Everything is just a stream of bytes, right? What happens is that there's encodings. Like the first 2 bytes will be some magic byte that tells you that this is an image and this is a PowerPoint file. And depending then on those first few bytes, it tells you the file type. Depending on the rest of the file, it might tell you other things about a file. And so magic bytes are important. You can take advantage of file formats to hide one type of file inside of another type of file. And I mentioned that a little bit earlier. And so that is some of the stuff that you'll see in these competitions. Network forensics is another big topic. So here is a whole bunch of here's just like a wiretap on this network. Tell me what happened. right? Like here is, here's a conversation that I recorded between two people, and they, in their conversation, talked about a location. Tell me what that location is. And that's one of the problems that we can go through. So understanding how to use the tools to do that, that's useful. Again, just understanding, like, Googling what tools do I use to look through network packets, right? Like I can tell you that there's some certain tools and they might point you at certain tools. So like Wireshark is the de facto network analyzer. There's also the browser-based version, CloudShark. But really, when in doubt, pick out keywords and Google them. That's what we're really going to do. Find tools. A lot of them that you'll need are to manipulate files. And I believe in one of my later sections, I list a couple of other useful tools that are useful for forensics as well as some of the other topics. But I have it in one of the other topic slides. What was that? All right. So I'm gonna pull up some problems here. I don't expect you to actually pull these up on your own. I have the link there for myself. Yeah, these are just names of problems. So let's actually switch over to this is not the actual competition that we're going to run, but this is a previous year's version. So the problems are very similar, which is why I picked this. Let me see if I can pull this. Ugh. Why is this so annoying? Sorry, full screen issues. There we go. There we go. Okay. And so we'll start with the beginning. So failure to boot. Yeah. There we go. Okay. So here's a type of problem that you'll see in this capture the flag. This is like the very first problem in 3 years ago, the 2013. Failure to boot. You open up a robot's front panel and it says blue screen of death. I can't boot. And you get this error. And you get this text. And it says file system recovery initiated. File system could not be identified. Tell me what format my file system is in. Where do we start? We Google it. What do we Google? The error. All right, Google it. Someone Google it and tell me what it is. Did you already Google it?
Yeah.
Go. It's a fat file system. All right, what does that mean? Someone else Google what fat file system is. Fat. FAT32. So fat. Correct. All right, like that's sort of, you Google it and you say, oh, it's got this connection to fat. Cool thing, FAT32 is a file format system. I believe that Windows uses that pretty heavily. So when in doubt, when you're trying to format a disk like an SD card or something, if you want it to work on Windows, FAT32. All right. So next one, we'll go through this one. So XML. This CTF has a story associated with it. We're not going to get into it for this year. For the one we're actually going to do, we can get it. You guys can do the story if you want to, but you don't have to. So a lot of this, it has to do with the story itself. But there's some book that we have for instructions, and there's an XML file that has a configuration key, but it's corrupted. All right. So like I said, like we'll encounter corrupted files. So let's open this file. And browsers like XML, right? Like browsers can parse XML and display it, similar to HTML. But that's the error I'm getting if I try to open this file. So what do I do next? Inspect. All right, let's open up the inspector. That's going to take a second because my computer is slow. Anyone else? While that tries to load. There we go. All right. So what do you want to look at in this inspector? Line 3. You got to give me a little bit more instruction than that. This is the I don't know how to make that bigger. Can I just make that bigger? Yes, I can. All right. So this is the HTML page that I'm looking at. Resources. All right. What am I looking at here? What do you want me to go through? Frames. All right, here's the XML sign flag. Can everyone read that? It's corrupted XML, right? So it's got some open tags. It's got some like random half open tag, some random text in the middle of it. It's like sort of XML, but not really. Is that readable? I don't know if that's quite readable at the back of the room, but hey, there's your flag, done. All right, another way, and a lot of times when you're looking at, I'll get to this in web exploits, one of the #1 things, instead of opening up the inspector, look at the page source. Because if you open up this XML file in a text editor, you would have seen that immediately. So let's copy that in. So this is really how you would approach this problem. So like, here's the flag, copy it, come over here, paste it, and submit it. And yes, that's correct, and I already solved it. Don't worry about that. Cool. Let's see. All right, so this one is a network analyzing problem. We have this robot is connecting to a network, and we got a capture of their communications. All right, we think, hey, they're communicating with some crashed ship, and we need to figure out where that ship is. All right, so let's take a look at this. This particular one is really nice because they already have all the files in CloudShark. So anytime they ask you to look at network packets, you don't actually need to download the packet file and open in Wireshark. You can go in your browser to CloudShark. All right, and so this is what network packets look like. Has anyone actually seen this before? We got 1, 2, 3-ish. All right. It's confusing. There's a lot of stuff going on the screen. It's also small text, so you can't see it in the back. I can make that bigger. Cool. So each of these lines is an actual packet. It's got a lot of metadata and what's important. We've got IP addresses, source and destination. Depending on how much information you have, those might be translated into host names. It depends on what you're looking at, how much other information you have. We have protocol information about what they were talking over. What this packet is DNS packet. This packet is a TCP packet. We have the length in bytes, and we have some information that CloudShark or Wireshark is able to pull out of that packet. Right? So it's able to say, hey, this is a SYN packet. This is a SYN ACK. This is an ACK. That's a TCP handshake. And I can recognize that because I know a little bit of what the TCP protocol is. But that's some of the things that you might want to Google. You might want to say, hey, what do I need to look for in CloudShark, in Wireshark? Like, how do I look for, like what is a SYN, right? That's stuff that will come up. In this case, the question was what? The location. But what else were we prompted with? What other information did we have? Let's go back to it. Good. That's a good point. Let's go back to it. So so they communicated, right? So they had communications. We captured all the packets, and we want to figure out where the location of the ship is, right? So where should I like conceptually look for that information? Maybe not like in the specific CloudShark, like what do I click on, but how do I want to get to that information? No, that's fine. Okay, so you want to look for the connection. Sure. I can give that to you. So this synac ac, and then following that is going to be actually, this is just actual connection information. So these packets consist of, like, this is their actual conversation.
Is it just when they do that handshake? Is the source and destination what we're looking for?
So that's the key question, right? What are we actually looking for? We're looking for the location of the ship, but what does that mean? Does that mean, like you're saying, is it just the IP address of where the source is? We can try it, right? But which one? 107? Okay, sure.
Yeah, there are only two.
There are only two because there's two people communicating. All right, let's copy it and try it. No. What else could a location of a thing be? Geographic, but how geographic?
URL.
Coordinates. URL. This is also tying into a story.
Okay.
And in the story, there's like an alien robot that's landed, like crash landed in your backyard. And it's trying to figure it out. What's up? Okay. So what you're seeing is one of the features of Wireshark, which it can take the IP address and those, because of how the internet is laid out, are allocated, associated with different geolocations. Just because I don't want to spend too much time on this anymore, I'm going to say that we're not looking for the location of IP addresses. We're looking for something that was actually communicated in their conversation. All right. So we want to try and figure out, okay, how can we look at what they sent? Can anyone Google it and tell me how we might be able to look at their conversation? I mean, we have all the packets, but maybe there's a capability in this tool that lets me kind of pull out what they sent. Okay, so simply clicking on a packet will pull out the raw information of this packet. And we'll be able to see, like, this packet has this information, and like we can open up the TCP and see, okay, it's got this data, right? And here's the actual packet down here. I'm going to give this one to you again because I want to kind of just move on. CloudShark, this is not something I expect you to actually know. This is something that you would Google and you would figure out, but it will take you a little bit of time right now. CloudShark is really cool, and if you have a session, you can say, hey, take all of the packets out of this session and reconstruct them and tell me what the session said. Like, show me what both sides of this conversation said. So we'll do analysis tools here, and it says follow stream. And we'll get a little pop-up that says, hey, look, these are the messages that were sent by both sides. If you have a wiretap on a network, you can do this. This is how you capture passwords that are sent over HTTP. Packet capture them. You can pull them directly out of the text stream because it's not encrypted. If it's encrypted, Wireshark needs to know a little bit more. If you have the key, it can try that. There are other tools that will try to extract a key from the messages, but this is network forensics, guys. This is this is what people do. So if we look in here, anyone see some stuff that we care about?
Coordinates.
Coordinates, cool. That's the answer. I'm not gonna continue with that one. All right, spaceport map. That's a cool, different one. Okay. Hey, there's a, oh dude, that's tiny, that's huge. Here's a map of a spaceport, and there's some hidden information. And I'll make it a little bit smaller. Take a look at it real close. All right, it's a GIF. GIF, I don't really know. But like, there's some hidden information in this image. Where do I start? Yeah, there's stuff changing down here. I made it. Sure, I'll make it big again, and we'll just look at it there. So there's a whole bunch of German, and then every so often, you get something that flashes really fast and goes away. So it's probably the hidden thing. Where do we go from there? Download it. I don't even. I mean, I can, but I don't need to because you have something else in mind. What am I going to do with that downloaded GIF? Split it. How am I going to split it? So Google the same thing, but now now add the keyword online to it, because almost all of these tools have like a version where someone just hosts it online. So follow that same train of thought, and if someone else beats him to it, just go for it. Yes, he beat us all to it. But basically, you can go online and you can say, hey, give me a website where I give you a GIF URL and you extract all the images from it. All right? I mean, this is where you Google. You have a train of thought and you Google and you say, did anyone make this already? Like, probably the answer is yes. It's kind of like Rule 43, and I'm not going to explain that if you don't know what that is. 34. I'm sorry. I even got that wrong. Don't Google that one, guys. Don't do it. If you don't already know what it is. All right. I've got two more. Bytecode. All right. So here's another one. Here's again a different style of forensics. We want to retrieve some password to get into some area, and we've got a file that they're giving us. It's a class file that's got some executable on it. I've got it on my computer. Let me pull it up. And sorry, that's my computer just catching up. All right, so that is this file right here. I should make this bigger. Okay, so that file right there. Let's unzip it. Let me actually get rid of the other stuff. And I think so. For things where you're dealing with files, they say, hey, here's a file, find the flag. I would suggest getting comfortable with the terminal. Figuring out like how to do stuff in the terminal to do this. You can open this up in a graphical editor and say, hey, computer, unzip this file for me. But then you're going to get a class file, and how do you view a class file? Do you like pop it open in a text editor? Yeah, you can do that. But you should like kind of get familiar with it. A lot of times using a terminal is easier and faster than trying the graphical editors. But so if you have a zip file on a Mac, unzip. We'll just unzip it. And we've extracted, it's still really small. We've extracted this thing called authenticator.class. All right, where do I go from here? Open it. I got a suggestion for less. All right, it's a binary file. You want to see it anyways? Yes. All right. What do you see in there?
I see this is the magical string by 166.
You see strings. Strings are cool. And strings in executables are readable. That is, in fact, the string that we care about. And I'm going to show you one other really cool Unix utility called strings. What it does is it takes in a binary file, and it just prints out all of the strings that it can find. Very useful utility for both forensics and for some of the reverse engineering, and for some of the binary exploitation. Like a lot of these kind of go hand in hand. If you're looking for strings, use a utility called strings. So a lot of times, the lesson here is really, there might be a utility that does what you actually want to do. So maybe ask one of us if we know about it, or try to Google to see if this exists. If it doesn't exist, then you use less, you copy it out some other way. It doesn't really matter. All right, so that is exactly, this is the magical string. That's it, that's the answer. Oh my God. Pilot logic, okay. Computer, why are you so slow? All right. So this is the other, this particular competition has another type of challenge that it'll give you. They're running a server, a game server, that has a lot of their programs and like binaries and files and stuff hosted there. So they're saying, hey, log into our server, and here you'll find, like in this directory, you'll find stuff. And we want you to go through it and figure out where is the password in this bunch of stuff. It will be useful to either use SSH to log in here, or this picoctf. You'll see this when you actually get started with this. We've got a little shell. It's not actually going to work for some reason for the 2013 one for me. So I'm going to SSH in. Wonder if I have this open. I don't know if I actually have this open. I might actually, okay. So we'll go to the shell. picoctf will have, like, it'll give you the username to log in with, the password to log in with. You'll see this in the actual, when we start the actual competition, you're going to need this too. This is why I'm kind of walking through this. Not this particular one, but you'll need this in the actual competition when we get there. So. How many of you have used SSH before? All right. So when you're doing login from a terminal, passwords don't appear. That's just something to like be aware of. If you've used the terminal before to like log in and SSH into things, you've seen that. If you haven't, it's going to be like, you're going to be shocked and you're like, why is nothing moving? It's still accepting your password. It's just not displaying it to try and be secure. So don't freak out if you don't see your password being typed. All right. So let's go to that folder that it told us about. I believe it was problems. Pilot launcher. How many of you guys are familiar with the terminal? Like how Linux terminal works? How many? Okay, so a lot of people are not at all familiar with that. It might be helpful to Google a like kind of terminal cheat sheet of how to maneuver in a terminal. So things like, how do I move from this directory to another directory? right? There's a command called change directory, so cd, which I have at the top there. Things like, how do I list all the files that exist in this directory? The command in this case is ls, so for list. In this case, the forensics task is the password in this set of files is hidden somehow. Uncover it. All right, so you need to know, so I'll give you that much, and I want you guys to Google and figure out how people hide files in the Linux file system. And how can I uncover them? -A. All right, ls-a. Okay, I see more things. Can someone explain to everyone what those dots are? Explain to everyone else, not to me.
Yeah, we haven't really done anything special because one dot is just the current directory and two dots is at one level.
Okay, I mean, this is for people who don't know what the shell is. This is how Linux handles it. You'll see this, like this is just to understand what's going on. One is where you are now. Two is your parent. Okay, what else? What else can we do? ls-al. Okay. Capital. So A shows everything, which is the right command to use. Capital A will hide those two specific directories, the current and parent. Those are like special directories. Still haven't found it. I haven't told you anything. Let's look in Lost and Found. That's a good place to go. Permission denied. Can't go in there. Let's try it. Permission denied. I don't think I have sudo on this machine. No. Sorry. Let's try the other directory. Let's try home. Okay. What else do you want me to do? ls. ls.hal. Yes. Is there a Google it? That's a great question. Figure it out. Tell me what to type.
I think it's ls-r or ar, but I'm not sure. How to list all the files.
AR? LR? Both capitalized. Like that? Apparently there's a lot of cat pictures in here. So let's see what else is in here. Ah, you guys are losing track of the problem itself. We're looking for the pilot's password. So yeah, this is so I'm doing this and I'm making you tell me what to do because I want to try and like show you how to approach these problems. But I'm not actually just gonna like tell you how to approach them. I'd rather you tell me how to approach the problems. But like that's a good question. Like I forgot what I was looking for. I need to go back to the problem and figure it out again. Or I'm making assumptions about like, does it have to be in this directory? I need to question my assumptions, right? Which you did, and then that led us down this path to find all the cat pictures. So yeah. So where do you want to go from here? Yeah, so the file system is in pilot logic. That's the problem told you that. Yeah. grep -r. What's grep? Explain.
It searches a file to find any occurrences of the word that you put into it. And a grep-r
Okay, so grep-r, what are we looking for?
Password and maybe passwd.
Password. I'm gonna throw in some fancy. All right. You want to search those two strings
Sure.
in what?
Everything.
In everything. How do I do that? Pipe? Tell me. You guys are telling me. I'm not telling you. How do I use grep?
How do you scrub? Does an R do it? Yeah, I mean, shouldn't we just hit it? Let's just try that. I think it's gonna work on everything. Oh.
Someone who knows the terminal, tell me why this is not working.
Semicolon. No, I'm not good. Semicolon.
I can.
Only works in Mongo.
Same result. We need a file name. Yes. So grep, when not given the file name, what does it use?
Yeah.
Let's try that. If you're not given a file name, grep uses standard in. So it's waiting for me to type input, and then it will tell me that my input matches the text string. So this is the other thing that's weird. Look up how, so we're using a program called bash as our terminal. Look up how bash regex is different from normal regex, because it's different. Yeah, so like you'll encounter all of these things, and you need to go down this rabbit hole of like, wait, this is not doing what I want it to do. How do I make it do what I want it to do? All right. Also, we're getting into timelines, so I'm gonna take over this one. We want to find LAR pilot. Here it is. So PilotBot has a directory called .secret, and inside there's a file called key. This is what you're supposed to find in this case.
Wait, can you what do you
so it was very similar to what you guys were talking about. ls-l, so L is give me in long format. So instead of just listing each file, give me like all of this extra metadata. Not really that important. A is for show me everything, including hidden files. So you guys were on the right track with this dot. In Unix, if you put a dot in front of it, it hides it. It's kind of like in, I guess Mac does the same thing. If you have a dot and then anything, it won't show it in Finder unless you explicitly tell it to. So we have a .secret folder, and then inside there's a key. And you look at the contents of that key. Here's another Unix command, cat, or contents. And let's go into pilotbot.secret key. And bonus points for anyone who can name where that quote is from. Yes! I really love the show. If you haven't seen Firefly, I would recommend it if you like space and you like cowboys, space cowboys. Not going to say anything more on that. Okay. All right, so that's all I got on forensics. A lot of forensics is just like, I don't know what I'm doing, ask the Google God. That's it. Really. Like all of what we just did. Ask the Google God. All right. I'm going to try and go a little bit faster so we have more time for the actual competition. Yes. Okay. All right, so we're going to skip XKCD. Reverse engineering is all about understanding what code is doing. And a lot of times this will help you find logical bugs in your programming. And like, it's really an interesting exercise in understanding what something complex is doing. Practical application and security, malware tries to actively hide what it's doing because it's malicious. And so for security people, we want to know, are you actually malicious? What are you doing? Like, how are you affecting my system? So reverse engineering is the tool that we use to do this. These were 2 examples of really weird obfuscated code that I'm going to skip. So really the things with tips on this is look at source code. If it's in a language you don't understand, look up the syntax. Grab paper and pencil, write down, try to trace through what stuff is doing. If you don't have the source of it, then you're probably given a binary, right? An executable. Then disassemble it. If you were here last week, we talked about compilers. There are tools that will decompile programs, taking a binary and trying to give you source code. It's not an exact science, but that's how you're given a binary, try to reverse it, and then read through that to figure out what's going on. Here's just tools that might help when you're coming across these problems. Strings. Object dump is to look at look at executable files and figure out how they're laid out. I can't really say much more about that without going in way more detail than you need, or than I have time for. A hex editor means these files are in binary. There's just like zeros and ones. It's not ASCII stuff. You saw that with the class file that I tried to open. Figure out how to view native hex. And you may or may not need that. And debuggers are also really useful. You guys have seen that with JavaScript debugger. There are other debuggers for executables where you can stop and look at the state of what's going on. I'm probably going to skip these for now, and I'll come back to some of these reverse engineering problems if we have a little bit of time. OK, binary exploitation. What is this? I think I said this earlier. You've got some code running. I want to make your code do what I want. And so binary exploitation, depending on the problem, requires different levels of understanding. Sometimes you need to understand how a particular language handles a particular function, right? So like Python has a function called eval, where it will just take a string and interpret it as Python code and run it. That's incredibly dangerous. Because if I give you Python code and you just run it without looking at it, like I've just won. All right, I can do whatever the hell I want on your system. That's it. You're done. Understanding how data structures work and their representations in memory. So things like how are integers stored in memory? Is your system using 32-bit integers? In which case, OK, that means I know that this number is the maximum number that you can represent. And if I take 2 numbers that are really close to the maximum, add them together, I'll get a negative number because of integer overflow. And understanding how strange things, because of how things are represented in memory, will affect the running of the program. The PicoCTF will actually, some of the example problems will walk you through at least one of these overflow bugs. Kind of looking at assembly and understanding how it's laid out can be useful. Not so much for this competition, but if you want to do this in further competitions, the current state of the art in binary exploitation, like things that hackers are actually using in the wild, are all about code reuse. So we've mostly solved the problem of you give me your code and I run it. Mostly we say, OK, no, you're not allowed to just give me code and I won't just run it. I'm going to do some sanity checking. I'm going to make sure that it's not something I don't want to run. But instead, hackers will look through your code and say, hey, if I look at this instruction and instead of running it from the beginning, I jump to the middle of your instruction and I run it from there, it does something that you don't want to do, and it does something that I want to do. So it's what's called code reuse. Or I can just use your function that you have written, but I'll give you my input, and I'll put that input in your memory. And so that's the current state of the art. A lot of the competitions actually do have, like some of the harder challenges require you to build these sorts of exploits where you do a code reuse attack. You build upon finding code that you can use and launching it. Understanding how memory is laid out, a lot of that has to do with like, where is like this variable is next to this variable. So if I have an array here, a string or an array, and I have some secret over here, if I write something to this array that's larger than the array, it's going to overflow and hit this secret. And so now I have control over the secret. So understanding like how things are laid out is useful for that. Again, PicoCTF has an example where they walk you through that, which I think like is really, really valuable. They walk you through it visually. They kind of show you how things are overflowing into other things. And then understanding how processors execute is also can be really useful. I'm not going to get more into that. So there's different types of corruption. Logical corruption, 2 + 3 = -3. What? Anyone have a quick answer as to why that might be true? That's fine. It has to do, it has to do with how integers are represented. In this case, I'm only storing 3 bits. I only have 3 binary bits to store my numbers. I can't store 5. Or sorry, I can store 5 in my 3 bits, but if I also want to store negative numbers, I can't actually store 5. I can only store 0, 1, 2, 3, and -1, -2, -3. I can't actually store other numbers. So 1, 0, 1 turns into -3. Don't really worry about why that is. If you're interested, I can explain it to you after this. But this is the sort of overflow that we're talking about when we say, like, if you have signed integers, you can get 2 positive numbers added together gets you a negative number. This is one of the intro challenges in the actual competition. And then memory corruption, which I talked about a little bit. Buffer overflow is the classic example. Again, it's one of the challenges that you'll see in the competition, and it walks you through it. Yeah, these are, I'm not going to worry about these problems right now. Web exploitation. So the things that you'll see in this challenge that you won't, or that you probably won't see as much of in your red-blue game later this week. So what web exploitation is, in general, is I want to make your web server or someone's client do something that isn't intended. I want you to allow me to log in as an admin. I want you to reveal your secrets to me. I want to be able to say that, hey, you're going to transfer me all of this money because you clicked on some link of mine, right? So general tips and hints: look at source, look at comments. Like, first thing to look at almost always when you're looking at web exploits is look at the source that you have available. Look at the HTML source, look at the PHP source, look at the JavaScript source. A lot of times you can look at it and understand it, and you can say, hey, it's vulnerable there. This is doing something that's weird. I can give it my input and it'll just run it. Look at cookies. Look at request data. So cookies encode session information. You can change them. You have control over them. You should, if you don't know how to, Google it. Figure it out, because it's actually really useful. And then you'll take this outside and you'll start messing with your cookies, and like things will change. Request data, what I mean by this are like get parameters, post parameters. You should be familiar with how to manipulate those. So if you don't know how to, Google it. it's in, when you open up your inspector, it's in the, I think it's network. You can view a request that was sent, and you can change the parameters, and you can relaunch it. So understand how to do that. Those are cool things. Undocumented functions is a problem you'll see in the competition. So it'll say, hey, I want to launch this function, but there's no like link for me to click on. How do I get there? Some of the big companies have actually had issues with this. So they'll have undocumented functions in their API where people start using them and they get more information than the company intended to reveal. I believe that like Twitter and Facebook have had problems with this in the past, where they left something in maybe for debugging, and they accidentally made it public, right? But it's not documented anywhere, but someone finds it, and then that's bad. Injection. Here we're talking a lot about SQL injection. So the famous Bobby drop tables. You will, and there are a whole bunch of really cool challenges that involve different levels of injection, and they get harder. In this case, I'm running an SQL query, but I'm not sanitizing what you give me, so you can give me special characters. And now your special characters have meaning in my query. Yeah, okay. I ran through that really, really, really fast. Are there any specific topics that you guys want to try and do an example of all together, like as a whole group? No. Cool. Yeah, that's exactly what I was going to go with next. All right. So I think, yeah, we're gonna switch over to the actual competition.
You just put a put request on your user ID.
Okay. So more on that in a bit. All of you are hackers. Now we are. So.
Do you want the display?
Sure. Actually, I don't need display. So,
okay.
So here's what's here's what we're gonna do for the next few hours. This is actually the part where you really get to implement some of these things, and I think what Veer was trying to demo is just the process of like just randomly checking stuff, poking around. And I think it's not necessarily a set. There's not always a set process for everything, but if you just keep that poking around feeling in mind, you'll be fine. What we're gonna do next is play this. There's this game called Pico CTF. CTF stands for Capture the Flag. And what Capture the Flag means is that, if you've ever played a Capture the Flag, which is like using a real flag or frisbees or something like that, you know that usually, basically, there are two teams, and one team is hiding the flag, and they're trying to prevent you from getting it, right? And so in this case, you are also basically on a team, and the other team is basically the server, and there's some flag that's hiding somewhere, and you have to, run some exploit to get to that flag. And you'll see each challenge has a different scenario. Most of the challenges also have hints, which you can use for free in a sense, meaning you don't lose any points if you look at the hint. But just for your own fun, you can, maybe try it before you look at the hint. The hint is usually I think it gives you a good like 1/3 progress. Like they're pretty reasonable hits. And so the way it will work is that there's a workshop that outlines these instructions, which I'll open up to you guys quickly. But we're gonna pair in teams of 2, and then each team will be registered in this Pico CTF platform, and you basically just get points for every challenge that you solve.